slide 11 or something.
Yeah.
Or 2000, okay. Yeah. How do you come up with this number?
Okay. I read article on the news report on the internet. Yes.
Okay. Right. So the more serious question is the following. So I think you might have said at some point that you could just do room temperature measurements, and then you would be able to deduce whether they work well at low temperature. Did you say something like that at some point?
Which device?
I don't remember precisely, but I might have. Okay, maybe I might have misheard that.
Can you repeat again?
Yes, I say. I think I might have heard you saying that you just need to do room temperature measurements, and then you will be able to tell whether it works well. Yeah. So to me, it's kind of surprising, right? Because isn't that kind of assuming that there will not be any kind of phase transition when you lower the temperatures? Because properties could change drastically, right, when we change the temperature.
But there's no any phase transition in this measurement. What phase transition do you mean?
No, I'm just saying that if you do room temperature measurements, right, if that allows you to deduce the properties at low temperatures, then I guess you're kind of assuming that the properties stay the same when you change the temperature.
The trend is the same, yes.
But that is
for example, you lower temperature, you increase the mobility.
Yeah.
Yeah, something like that. I'm not sure if I answered.
Okay, maybe we can discuss offline.
Oh,
okay, thanks.
Yeah. Thank you.
Okay.
Sorry, I can make a quick comment on that because I've been discussed this with Frank. I think for this particular silicon is well known. So for the electrical engineer, they know almost everything, so they can measure the room temperature property, and Frank are trying to build a model. So depending on a certain range of temperature variation, they will be able to expect what kind of the, like a property or functionality will go when you go down to the low temperature. Of course, he also asked me to do some of the demonstration to verify whether the model is correct. I hope it kind of answered the question. So, but it only happened for this silicon. If you're going to topological material, some certain strongly correlated system, it doesn't work.
Yeah, this is a well-known system material.
Okay, do we have one last question? Okay.
Yeah, following the same question that when you say you have this correlation, but I kind of remember that you also said that this correlation break down at a low temperature for certain cases, so that is say limited by short channel effect or something. Is that right?
Well, the device I'm using here is very large. If I remember correctly, the channel length here is 10 micron long. So I would say that the uniformity is good. The variation is also very small. So that's why we can make this correlation. Yeah. Well, it's correlation for bulk material, you can say.
Okay, well, let's thank Professor Gao again.